Hello everyone, I am Dr. K, your instructor. We are going to show you some simple examples using non-OOP and OOP paradigm. After this presentation, you should be able to see the differences of using OOP and non-OOP paradigm in writing Python programs. I will give you two examples to help you understand the concepts. First, we show you a simple example using Python's functions. Second, we rewrite it using the OOP paradigm. Third, we further enhance it using OOP's polymorphism feature. Then we go through these three steps again using a slightly more complicated example. We have a simple program to calculate the area of two simple shapes, a square and a circle. We first define a function to calculate the area of a square. Next, we define a function to calculate the area of a circle. We want to calculate the area of a square with a side of 5 units. And the area of a circle with a radius of 3 units. We pass the side and radius to the functions of calculating the area of a square and circle respectively. And we can print the results out. Let's rewrite the program using the OOP paradigm. We first define the class shape with two attributes, side and radius, which could be optional using the none keyword. Then we define a method to calculate the area of a square, and a method to calculate the area of a circle. In our main program, we use the shape class to create two objects, object square, with a side equals to 5 units, and object circle, with a radius equals to 3 units. Then we can calculate the areas of these two objects, square and circle, and print the areas out. But hey, we are not using one of OOP's strongest features, polymorphism. So let us rewrite it using polymorphism. We first define an abstract class shape with an abstract method area. Then we define two subclasses, square and circle. In the subclass square, we take the side attribute and use it to calculate the square's area with its area method. In the subclass circle, we take the radius attribute to calculate its areas using its own area method. In the main program, we create a list shapes that contains instances of the square and circle classes. Then, we iterate over the list and call the area method on each shape, using polymorphism to call the appropriate implementation of the method based on the type of the shape. Finally, we print the area of each shape, along with its name obtained using the type function. By using polymorphism, we can easily add new shapes to the program by creating new subclasses of the shape class, without having to modify the main program. This makes the program more flexible and easier to maintain. Now we look at a slightly more complicated example of a calculator using functions. This calculator can do 4 arithmetic operations: addition, subtraction, multiplication and division. So we define the 4 operations using function respectively. In the function divide, we check the division by 0 case to prevent any error. In our main program, we print the results out one by one. Let's rewrite the previous example using OOP. We first define a class calculator with two attributes A and B, and it contains 4 methods to do addition, subtraction, multiplication and division between two numbers. We create an instance C of the calculator class with two numbers 10 and 5. Then we call the 4 methods and print the results out. Now, let's do it using the polymorphism feature in OOP. We define a calculator class with two numbers and an empty calculate method. We then define 4 subclasses add, subtract, multiply and divide that inherits from the calculator class and implement their own calculate methods to perform addition, subtraction, multiplication, and division operations between the two numbers. We create variables for two numbers, and then create a list of instances of each of the 4 subclasses. We then loop through the list and call the calculate method for each instance, printing out the results alongside the name of the corresponding subclass using the class.name attribute. This example shows polymorphism by defining a common interface calculate that is implemented differently by each subclass, allowing us to treat each instance as a calculator object and call its calculate method without having to worry about the specific operation being performed. Wait a minute. Do you know that the examples I have just shown you are all generated by AI? AI is going to revolutionize many industries, especially the computing industry. We will look at how AI is changing the programming landscape in the coming presentation. We have shown you 2 simple examples to see the differences using OOP and non-OOP paradigm in writing Python programs. I hope you have enjoyed this lesson. Thanks, and see you next time.